This is an update to my transparent background converter that I did in the last video. I'll link to that in the description. But I really liked the project, but the only thing is the response time to do the conversions was kind of slow, and it made it kind of jerky when you're doing it. You can see it actually takes some time to do it when it does it. You see you're not as responsive as you should be. And I had actually read somewhere along the way when I was researching how to do this that Numpy, if you could figure out if Numpy would do it quicker, because the code behind Numpy is actually C code. And of course, that's a compiled code down there, and it runs faster than the interpreted Python code. This Python that we're running has a lot of C stuff in the under the hood, so but it's still interpreted. I took a deep dive on why that was and everything. I also go ahead and close this one. I also decided, well, let me see how long this is actually taking to do these conversions. So I looked up, they have this performance counter that they have where you're, just times just getting one time and then a second time. Just using what everybody seems to use is tick and talk, and then you subtract tick from talk. And we're going out to 0.6 decimal places out there and printing it out. So I can run this, and this is just the basic program. Now, this isn't the loading the image or converting the image or saving the image. This is just between here and here is just this processing time that I got right here. So go ahead and run that. And you can see our processing time down here is about 1.89, about 1.9 seconds, basically, or not 1.9, 0.19 seconds, 190 milliseconds to process that each time. And so you can see, it's not too bad, and we could probably live with it. But like I said, I kept nagging me that I'd seen this, that Numpy can do those calculations a lot faster. I've probably looked at 20 websites and went through a lot of the pages of documentation of the Numpy, and it's some of that was really a struggle, and learned a lot about Numpy, but it took me probably 5 or 6 hours actually watching videos and looking through tutorials on the web and everything. I gotta admit, it's there if you can find it. And I'm usually a little bit better in finding these things, which it's all what you put in your search terms and everything. But I finally was able to come up with, after a lot of dead ends, was able to come up with a website that was doing something similar, but they weren't doing it. They were going for a single color, getting a single color. So I had to change it a little bit. Let's go ahead and comment this out. And we'll uncomment this. We're replacing all those lines with these 2 lines of Numpy code. And so what you're actually doing with this here, we went through and we were looping through, nested loop to go through each pixel on the screen, checking all 3 to see if they were above 200 or whatever our threshold was. And then if they were, then we were making the alpha channel 0 or transparent. So we, remove that pixel, that would become transparent. And then like I said, then we just, you know, updated the BGR, the image data. So we are actually doing all the same things up here. So what it's actually doing is creating the alpha channel, one where the RGB is, you know, 3 elements in that last part axis of the array, they call it. We were just creating another one. So what this does is it actually does a true or false. So it's saying if image is greater than threshold, then it's true. And that becomes a 1. And you multiply that by 255. But then they're doing this not up here. So I said, well, why can't we just flip this sign here and do this not? But it didn't work out. I think you're not getting, for some reason, the numbers aren't working out. So you're better off doing it like they're showing here, and then doing the not, so that anything above the threshold is going to become a 0 because of the not, because you're multiplying 0 times 255 is 0, or 1 times 255 is 255. So you're either getting because it's a if or you know, a Boolean there, that you're getting a, you know, just 2 values when you multiply it. So that's kind of cool. But that gives you your alpha channel. And then all you got to do is you take your image, and they have this D stack. And what D stack does, took a lot of reading, but what it does is it takes that 3-channel image, the BGR, and it actually adds the alpha channel as a 4th element. So it's stacking another element into that array. So that was even after I found this, I had to try to figure out what it was. And this all here takes all 3 elements and checks them, you know, the BG and R, and checks them. Where down here we had to go through, you know, is data 0, data 1, data 2. And this one just automatically checks all of them and returns it if they are all true. I think that's probably why this not is also in here, because sometimes if you have not all of them true, then it probably would return the wrong answer. So that's probably why we have to do that. I just happened to think about that. So anyhow, so we got these 2 lines of code, and like I say, most of this is C code in the background working, even though we're on Python. The Numpy library has a lot of C functions in it. So remember, we were at 190 milliseconds to do that. So let's run the same issue. So I actually have the image up here. So that's the image that we put out that we're saving. And when we run this, it'll update that image, and you can see that it's going to be the same. But this is the code, and we're going to run it. Look at our savings. We are at 0.00169. We have over 100 times faster by doing it that way. That just amazed me. They're 100 times faster. So just a no-brainer. So and as you can see, the image looks the same, does the same exact operation, except it does it that way. So anyhow, so I said, well, I just have to incorporate this into my GUI code. So I got it. I just added an NP on the end of it. So the GUI code basically what we got here is we had, so now if it's white, we just have these 2 lines of code. If we're trying to get rid of the white, and we're just, checking to see if it's greater than the threshold, and our threshold is up near 200. If we're working in the black, trying to get rid of the black, then it's less than the threshold, and our threshold is closer to 0. So I can show you that it works for both. So let's go ahead and run this, I guess. All right. So we'll just get this fall image, get it back up. Now look how responsive it is. It's just, I mean, as fast as you scroll it, it's just doing it. 100 times faster, you're not going to expect hardly anything. But I now call this part of the code complete. So that works fine, and I probably should show you that it works for the black one too. One with the black background, and we need to change this over to black. There we go. You can say this one's the one that has the watermark on it too, and you can get rid of that. But I mean, it just, fast as you can scroll it, it just updates it. No matter where you stop, it just automatic and almost instantaneous. So that's kind of cool. Probably could stop there on my project, but I have one more thing that's in mind. And what if we had something like this? And we want to keep the black, but not the yellow. So what I think my next step on this process will be to be able to click on a pixel on the screen here, and then have it subtract that color from the thing, and then probably have like a range, a tolerance on each side of it that, you can, so it doesn't have to be exactly that color, but really close to it. So I guess I got one more update to come along to see if I can get rid of that kind of stuff. I don't know whether you'll use that very often, but maybe logos and stuff like that, you want to get rid of the background color, a blue or a red or something like that, and I think it'll come in handy. Anyhow, that's my video for today. Update on the thing. I'm really happy with the way the Numpy works 100 times faster. Thanks, Paul, for all your teaching me Python. I wouldn't be anywhere along this way of doing things if it wasn't for you. Have a great day.